Good afternoon to all of you, those who are participating in this training program, especially our school teachers, those who are participating in this special program organized by IIRS on space technology and applications for school teachers. I will be giving a brief overview about how the space technology or the geospatial technology is being used for disaster risk reduction and the safety of the society. You must have come across various applications of space technology in different fields, but many of you are aware that we live in a world where large amount of natural disasters or man-made disasters keeps on happening. So in this talk, we will be trying to understand that how satellite data or the space-based systems, they are useful in terms of dealing with these disasters, in terms of reducing the risk of disasters, and how these data sets can ensure a safe society where we can live in harmony. Now, as far as natural disasters in India are concerned, India's geographical setting is such that it makes India a very vulnerable place to wide range of natural hazards. Particularly, we have flood seasons, and right now we are in entering into monsoon season, and already the floods have started happening. Many of you must have heard that already some area of Assam is under flooding. Recently, we have all seen the fury of cyclones, and especially the Biparaj cyclone, which basically struck the Gujarat coast. All of you have witnessed. Then, of course, we also suffer extreme heat wave conditions in the hilly regions and the hilly districts of India. There is also a threat of landslides. Then, forest area, especially during the summer season, also undergoes wildfires, or what we call as the forest fires. And of course, we also live in a very vulnerable zone, especially the northern part of the country, which are very highly vulnerable to the earthquake activities or the seismic activity. Studies are showing that climate change is also emerging as one of the potential, threat, which basically intensifying many of the, severities of these disasters which are happening due to the natural reason. And it has also been observed that the frequency of weather-related, abnormal situations like, flash flood kind of situations, cloud burst kind of situation, lightning, and then events like what happened in Chamoli, which was highly unprecedented in terms of flash flood without any rain event, are also increasing. So all these issues are concerning, especially all the residents of India. And in this map, we are trying to show you that which areas of the country are more vulnerable to different type of disasters, like northern territories, Himalayas. Entire Himalayan range is highly vulnerable to earthquake and landslide region. The northern areas of Indo-Gangetic floodplains like Assam, Bihar, and then eastern Uttar Pradesh, and of course some portion of the eastern part of the country is prone to the floods. Then the Bay of Bengal region, large amount of cyclone comes, so cyclone brings their own problems, especially when they struck the coastline. Large amount of flooding happens, and then the heavy wind also creates property losses as well as the losses to the human lives. Similarly, the east coast is also vulnerable to tsunamis, which are produced by earthquakes in sea. Then, of course, you have droughts in the central part of the country, and then in the western part of the country. So this is kind of a geographical distribution of various kind of disasters. Almost 12% of our land is flood prone. 8% of our land, which is around 7,500 kilometer coastline, 8% of that coastline is highly prone to cyclone effects. And we have been seeing that cyclones are occur also now increasing in the Arabian Sea. This time we have seen a very long lasting cyclone. And then 65% of our land is under cultivation. So we have land which is also under irrigation, but large amount of land is what we call as the rain-fed agriculture, so which is prone to drought in terms of failure of monsoon rains. Then 25% of our land, especially the land which is falling in the seismic zone 4 and 5, 5 is also earthquake. Himalayas and the Western Ghats are also land. Islands like Andaman, Nicobar of East Coast and Gujarat coast, they have basically also been, in historical aspect inundated by tsunamis. So we are almost throughout the year having danger of different kind of natural, disasters, which keep on occurring. And in 2021, World Meteorological Organization has brought out a report that India almost lost around $87 billion worth, you know, in terms of infrastructure in the year of 2021 due to the natural calamities. So you can see that the kind of investment which is basically getting affected apart from human losses is also on rise as the number of years, as we are, if we see from 1979 to 2010 or so. So, at international level also, strategies are being formulated that how we can minimize the risk from these disasters. See, natural disasters will keep on occurring. You cannot stop, humans cannot stop the natural disaster. But what we can do, we can basically reduce the risks and the kind of losses which are involved in terms of these natural, disasters. Considering international efforts have been made at different forums. So there is a very famous, framework called Sendai framework, which was adopted in 2015 and which is having a duration of around another 15 years or so. And under this broad umbrella of Sendai, it has been agreed upon by various governments that we will be working together in terms of identifying the risk, in terms of reducing the risk, and then also create financial instruments like risk transfer in terms of insurance, etc. also. So the basic aim is of the Sendai framework is to achieve the substantial reduction of disaster risk and losses in life, livelihoods and health, and the economic, physical, social, cultural and environmental assets of persons, businesses, communities and countries over next 15 years or so. And what are the major priority actions? Priority actions are basically to understand the disaster risk. That means why the disaster occur, what is the physical basis of this disaster, what is science behind it. Then we can basically strengthen the disaster risk governance to manage these disasters, invest disaster risk reduction for resilience in terms of creating infrastructure, both in space and ground, to know more about the disaster, and then develop early warning systems to facilitate our countrymen to warn them substantially ahead in time when a disaster is likely to struck. So by doing these kind of actions, what we are planning to achieve is basically 7 targets to considerably reduce the disaster mortality by 20, number of affected people reduction by 2030, economic losses or to be reduced substantially, infrastructure damage, and then what we have to increase is the disaster risk reduction, national and local strategy making, international cooperation by data sharing the best practices, and of course sharing the boots on the ground like NDRF, SDRF supports, the way which we have showcased during the Turkey earthquake, and then also information generation on the early warning systems and disaster risk reduction initiatives has to be enhanced. So all these activities has to be done by the countries which are signatory, and India is one of such signatory to this Sendai framework of disaster risk reduction. Now, apart from ground-based systems, satellite technology also plays a very important role in terms of preparedness of a disaster, in terms of providing early warning, in terms of responding once the disaster has happened, and then once disaster has happened, what we need to do is to recover also from the disaster. So in all 4 phases of disaster management, preparedness, early warning, response and recovery, space-based data sets are providing valuable assets in terms of dealing with the disaster, or what we call as the disaster management issues. So when it comes to preparedness, So we can create the hazard zonation maps like floods. Flood keep on occurring every year. Now every year we have lot of information about the flood occurrences. So can we create a flood hazard zonation map? Seismic micro zonation map. What are the areas which are most vulnerable to the agriculture droughts based on the previous historical data sets? And then based on these data sets, we can identify hotspots and take preventive action well in advance. And then, of course, National Disaster Management Command Center has, or NDMA, been set up in this country to deal with the preparatory aspects of the disasters. Similarly, we need to build the early warning systems. See, today, especially cyclone is a very good example. 5 or 6 days well in advance, when the cyclone start forming, what a process called cyclogenesis, we start providing, advisory services to the citizens. And 4 to 5 days in advance, we are in a position today to tell that such a such cyclone is now forming and it is likely to hit this part of the coastline. And as the, the date of cyclone hitting the coastline comes nearer and nearer, mid-course corrections are also being provided using numerical weather forecast model by assimilating the observational data from satellite systems into this model. Similarly, we are also developed very effective flood early warning systems in this country. Then landslides, some experimental work has been done at different locations, like rain-triggered landslides. But I will say that it is more or less R&D domain. It has not been fully operationalized. Extreme rainfall events are now being very successfully being forecasted. There is a term we call nowcast. That means any weather forecasting for next 3 to 4 hours. Today we are very successful in terms of extreme rainfall weather forecast prediction by our India Meteorological Department, where large amount of space-based satellite data also goes for weather forecasting. Heat wave and cold wave weather forecast is also pretty good. And then earthquakes are, not very reliably. We cannot, in fact, earthquake forewarning cannot be done at all. Only people are trying to rely on some precursor studies that whether, some warming happens, some radon gas leakage and other precursors happens or not. But conclusively, today we are still not in a position to provide any early warning about the earthquake related activities. Similarly, when a disaster is struck, we provide the response. That means we are now in a position to tell which areas are, let us say, flood inundated by doing rapid assessment using satellite data sets. In case of wildfires or forest fire, we are able to rapidly assess how much area has been under the forest fire, how much area has been burnt using satellite data. And then during the disaster, sometime, the communication network also fail. So satellite based communication network also becomes very handy in terms of providing relief, rescue, coordination of, disaster activities by NDRF, SDRF, local administration. So immediately some kind of satellite-based communication setup is commissioned when the local ground-based, telephone communications either by mobile or by phone lines got disrupted. Similarly, when it comes to recovery, once a disaster happened, everything is over, you want to reconstruct. So there is something called how much amount of money will be required to do reconstruction. So that assessment, how much damage has happened, what kind of damage has happened. So those damage assessment, etc. Space data is also very important. And of course, also to find out rehabilitation zone. See, like you must have heard about cases like, Joshimat, a lot of problems are happening. People are now trying to get, so government is trying to relocate those people. So we have to find out, suitable areas where these people can be relocated in terms of assessing this vulnerability to multiple hazards. So currently, as you must have heard in different lectures, we are operating different type of satellites from lower Earth orbiting platforms, from the geostationary platforms, from, we also collect a lot of data from our aircrafts, by UAVs and by ground-based sensors. So a combination of all these data sets today is being used for enhanced support of disaster risk reduction, for early warning, communication, location-based services, and also, to provide large amount of, effective flood management tools to various stakeholders when it comes to dealing with the disasters. Now, ISRO, in Department of Space, we have created what we call as the Disaster Management Support Program. We are only providing a support service to various, agencies which are involved in disaster risk reduction, mainly the National Disaster Management Authority, Ministry of Home Affairs, State Disaster Management Authorities, Ministry of External Affairs, then Geological Survey of India, Forest Survey of India, and now NDRF and SDRF. These teams also use this, information which is getting captured from space-based platform. So we are currently operating with a vision to provide space-based information during all phases of natural disasters in preparedness, response, mitigation, and reconstruction phase of disaster risk reduction in this country. We are dealing with floods and cyclone. We provide near real-time mapping during the flood activity. We also provide state-level flood hazard zonation, atlases. We have also developed methods for special early warning systems in this country, where up to 2 days in advance we can do forecasting that this area is likely to get inundated by flood. In case of forest fires, automated forest fire alert systems have been generated. Rapid assessment after the fires have happened is also provided to forestry officials. Then in case of landslides and earthquake, how much area has been damaged once a landslide or earthquake has happened, that rapid assessment is being done. Then NRSC, along with other partner institutions, have created what we call as a national landslide inventory. It is basically a kind of an inventory of all landslides which has happened in past. So we know which are the most susceptible regions, or landslide susceptible regions have been mapped in the country at the district level itself. Then all this information needs to be disseminated now through some other web-based systems like portals or maybe geo portals or kind of apps, etc. So we have generated what we call as the National Database for Emergency Management Dashboard, which is generated here at NRSC. And using this dashboard, you can get at one-stop solution or one source information for all kind of disasters which are currently active in the country. So some of you can visit later on. I will show you how you can access this NDEM portal, and that will tell you instantaneous information about the disasters in different locations in India. Similarly, disaster, DS, PDNA tool, post-disaster, need assessment for financial, sanctions, etc. is also a very important aspect. Disaster recovery sites, all these portals cannot be at one place in the country, because if that site gets destroyed in disaster, you cannot get information. So we are creating the disaster response sites also for various infrastructures which has been created in this country. We also collaborate with international partners with different space agencies, whether in the public or in private sector, for getting the satellite data at the time of disaster using what we call as the international charter invocation. There are regional players which are helping. In regions like Asia, there is a such kind of a coordinated effort under a banner called Sentinel Asia. And similarly, people needs to be trained. Like we are talking to you teachers, we need to tell all the stakeholders involved in disaster related activities how to read these data sets, how to read these maps, and then how effectively you can utilize this information to provide relief and rescue to the citizen when a disaster has struck, or after the disaster, for relief and rescue related aspects. So currently, if you see what kind of space and ground systems we are having for disaster risk reduction, DRR means disaster risk reduction, to reduce the risk which are associated with disaster. We are using, a fleet of communication satellite for, emergency communication system. We are also having a host of Earth observation satellite from GEO, LEO orbits. You must have all heard these names: INSAT 3D, INSAT 3DR, ResourceSat 2, ResourceSat 2A, Cartosat series of satellite. Different type of satellite with different type of capabilities are being used along with international satellites. I will not go into details of each one of them. Some are working in the optical domain, some are working in microwave domain. We are also having a constellation of navigation satellite. Many of you must have been using GPS satellites. Your mobile phone provides your location through GPS satellite. Similarly, India has also launched its own navigational satellites for a regional constellation called Navik. And this also is providing, alternate location-based accurate services as far as the Navik support for disaster management is concerned. Similarly, at the time of disaster, we also have aircraft. So if satellite data is not available that quickly, we can fly our aircrafts and then generate flood maps or maybe damage assessment maps using both unmanned aerial vehicles as well as the aerial platforms activities now. This capability is also existing in this country today. I also talked about international cooperation. That means how international entities come together at the time of crisis. So there is a concept called International Charter for Space and Major Disaster, where on an emergency basis we invoke this international charter along with the space agencies like European Space Agency or French Space Agency or Chinese Space Agency or United States of Geological Survey, DLR, INPI. These are all the players. Now private players are also participating in the international charter activity, and we try to get as quickly as possible the satellite data, even if our satellites are not there. Whichever satellite is flying over that disaster site, the data will be collected and all the data will come to National Remote Sensing Center here, and then it will disseminated to people for quick assessment of damages. So like this is the map which you are seeing over here. This is the damage map of Tapovan, that power plant which got washed away in the Chamoli hydropower incidents. And you can see large amount of extensive damage. Here in this case, you can see two images, one before the flood and then after flood, how much area has been inundated. You can see so many fields, etc. Their houses have been inundated. So based on all this information, search and rescue teams basically on ground, they work, they go to those sites because this information is being provided on an almost near real-time basis to the teams working on the ground. So I would like to summarize, give you a very crisp summary that what are all kind of, data sets are generated and what information is generated and how this information is converted to knowledge for taking actions on ground. So like, this is the flood map. Now this image, what you see here on the left side is an image when floods were not there. This is the pre-flood map. And then afterwards, when the flood occurs, the water, you can see the river has breached its, boundaries, and then the low-lying area, the water has now, spread into it. And that areas can be generated as a flood map and then provided the information. Similarly, most of the time when flood occurs, clouds are there because the cloud bridge, and using optical remote sensing data, you cannot see through cloud. So we use something called what we call as the radar images. So all this black area along this river, once the flood has receded, you can see the river has come back to its normal condition. But before the flood, all around this this river, you can see more black area. So this black area is nothing but the inundation due to water, and we can generate this information over a period of time. So like Kerala in 2018, massive floods have happened. So not only we generated the flood map area, we also generated the duration of floods. It is also important that flood water is standing for how many days. If you have more than 2 or 3 days, a location which is under flood water, there are major other issues which are related to health. They starts cropping up. So it's not only the flood inundation of flood area, but the duration of the flood which also matters. And we provide such type of information to the stakeholders using satellite data also. And we have also set up early warning system for flood forecasting. So we use the weather forecast which is provided by IMD, India Meteorological Department, for the next 2-day rainfall, and wherever the heavy rainfall occurs, when this water falls on the ground, how this water will run off. That modeling is done, and based on this models, hydrographs are generated watershed wise, and then flood warning is also pre-computed, and then this information is disseminated through web portals, etc., to the concerned authorities on the ground, which are supposed to take care of flood situation on the ground along with the local administration. All these things happens in an autonomous manner, and today, using their mobile phones and then SMS services and then email services, this information goes to stakeholder as soon as the early warning for floods is declared. What you can do when all these things are not happening, so you can be prepared for any future flood areas, and How you can do that? You have to know which are the areas which are more vulnerable to the floods. So today we have been doing this flood mapping activity since last 20 years or so. So we have every year flood map of last 20 years, and then we have generated the cumulative flood frequency at 30 meter by 30 meter grid interval, and we have mapped those areas into different rankings. So very low vulnerability to very high vulnerability. You can see these pixels in pink are very, very highly vulnerable to a future flood. So whenever you are doing any planning for construction, etc., you have to take care all these aspects of flood vulnerability in the area, and then do the planning accordingly. Last year, what we have done in 2022, flood season, we have basically provided within 3 to 4 hours turnaround time pan India, throughout India, this flood maps, as well as the damage assessment maps using NRSC, and then 14 major states using encompassing 208 districts, and using more than 2,000 images were covered, and this information about the flood situations have been disseminated to the states, their disaster management departments, through Ministry of Home Affairs at New Delhi, and then National Disaster Management Authority. All these agencies which are basically concerned with the topic of disaster are basically integrated, and the information is being provided for relief, rescue operations, and damage assessment to the various agencies. These are some of the examples of this type of maps which we provide. I'll show you some of those later on also. So in last 1 year or last few years, major floods and cyclones around 15 states from 180 to 200 districts were monitored and mapped. 5,000 images have been analyzed for last 3 years, and then infrastructure damage assessment to all major cyclones were analyzed and was provided to concern. So what you see here, this is the flood map of entire country for 2022. All these areas which you see in red, they were basically cumulatively mapped, and one time or another they were basically under flood conditions in India. This is the picture at a glance for flood season in the year of 2020. Then in 21 also, you can see the floods were recurring at eastern UP and Bihar and Assam, but there were no floods in the central part of the country, unlike which were there in 2020. Similarly, in 2022 there were massive floods in Godavari Delta, which was not there the case in 2021. However, the flood intensity was lesser in Bihar and eastern Uttar Pradesh compared to last 2 years. So like that, for last 20 years or so, we have this flood mapping data, and using this data, we have created what we call as the flood zonation maps for the entire country using historical data sets. So these are some examples of the flood affected area. This is before flood. All this black area in microwave data, what you see is the flood inundation area. Similarly, this is another area called Polavaram in West Godavari district. You can see this island. There is a dam over here. But once the flooding has happened, you can see the dam was full, and the water was so high that it was flowing over the dam itself, and then most of the area was submerged. So this was done by using a very high resolution data available through our PLIDAS imagery, which is a French satellite, and this data was basically made available by Airbus through our international charter mechanism. Similarly, last year you must have heard that Pakistan, our neighboring country, it got basically badly affected by massive amount of floods. So you can see this is a pre-flood image here of Indus River around Baluchistan and Sindh province, and this is a lake already here. And you can see post-flood how much area is under water. Blue, all this blue area is underwater, which was basically before not there before the floods. So this lake which you see over here, it has basically almost 130 kilometers. It has become extended to 800 kilometers. So almost more than 900 to 800 kilometer area was under the flood inundation at this location itself. So this has caused massive problem for the food security also, because this water was stagnant for almost 9-month period or so in Pakistan. Now here I show you an animation. You yourself can see, how this is before flood, and this is after flood situation. Such a large amount of area was basically under flood, and which basically brought large amount of economic distress also in Pakistan, because food crisis also got created, and they don't have even atta today. The basic wheat flour is also not available in sufficient quantity in that country because of this massive floods which has happened in the month of August last year in our neighboring country called Pakistan. So not only for our country, we are also able to do and provide this information for our neighborhood. Mostly all the SAARC countries we are able to map using our satellites what is happening and what kind of disaster scenario is there in those regions. Recently, you must have heard that this Biparaj cyclone, which basically inundated parts of Gujarat on 16th, 17th of June, 15th June it struck. Then 16, 17, massive rain has happened in parts of Gujarat. So we immediately triggered the charter, and then you can see this is the pre-cyclone image and this is the post-cyclone our radar image. And then this is the inundation map. So what you see is in the blue, dark blue region is the permanent water which is there even when cyclone condition or rain condition is not there. And the light blue is the area which is basically nothing but which was flooded. So all this flood inundation area has been mapped very rapidly in Gujarat, and this information was shared by the local disaster management authority. Similarly, this is another district. This is the Kutch district, and all this light blue regions are nothing but the flood inundation area, and dark blue is the permanent water area. So you can see a good amount of area in Kutch district was inundated by flood, and massive destruction has been reported. And these maps are basically very helpful for the authorities to know which areas are underwater and where to plan for disaster risk reduction and relief for the citizens. Similarly, currently in this season, in the third week of June, the massive flood activity have started in the Assam Valley also. So this is a radar image which has been acquired on 18th June 2023 over this area in the Kachar district of Assam. And all these black portions what you see is nothing but the flood inundation area. So based on this and image analysis has been done by our teams, and all these light blue regions are basically the flood affected areas. And this information is also very useful for the local Assam government for planning for the disaster risk reduction and the disaster relief and rescue in these parts of Assam. So immediately within 3 hours or so of flood occurrences, we generate these maps and share with the flood relief authorities of state government. Now this is after the floods have happened. But suppose if you get a warning that you are likely to get affected by flood well in advance, that is what is called as the early warning system. So using, as I was telling you, digital, very high accurate digital elevation model, hydrological modeling, and the weather forecast of those areas for Godavari and Tapi River, NRSC has developed this special flood early warning system. So 24 hours in advance with an almost 87% of accuracy, with a lead time of 36 to 52 hours, we are now able to tell at a village level what kind of, flood scenario will be there, what will be the flood depth, up to what height or what depth the water will be there, and which talukas and which, villages are going to be most affected by a flood scenario. This, activity is now an operational activity, and we are now transferring this technology to Central Water Commission, which is an authorized, entity in Government of India to provide the flood forecast estimates. So this is a very interesting work, and this has been appreciated at national level at NDMA and including the Home Minister of the country. And now on behest of them, we are extending this type of work to all major river basins of India. Mitigation phase, I already talked about. Flood hazard zonation atlases has been generated for 8 states. And then, now we have also come out with a national flood hazard zonation atlas, which tells you about the severity of the flood hazard at different location by this color scale which we were talking about. Now, this was the story, or this was work which is being done as the flood circle. There are other kind of hazards also, like geological hazards, earthquake, landslides, the glacial lake outflows, then landslide driven outflows of the lakes. So many of these events are basically, keeps on happening in the mountain regions, especially in Himalayan regions. That has to be dealt in a very different manner. You have heard about the major rock slide event in Chamoli, which has happened, which has caused massive destruction down the line. So we are also working for assessing these remote areas. So we are using this remote sensing data for glacial lake inventory, and also identifying, what are the threats for some of the lakes which can basically get breached by a landslide activity or by an earthquake activity. What is happening to the glaciers? How the snow is melting in the Himalayan region? How rapidly these glaciers are retreating? How much amount of water retention, water potential of water retention is there? How rapidly these glaciers are losing their ice in view of climate change? Then forests also are, what is happening to forest cover, how the biodiversity is getting affected. Many such issues are getting addressed by remote sensing data today. So ISRO has a big program of monitoring the Himalayan glaciers, and almost 54,000 glaciers are there in the entire Himalayan range. And many of them are basically receding, or they are going back because of the increased amount of temperature in Himalayan regions, which basically produces a long-term threat about the availability of water in the North Indian or Indus basins. So this is one, a small animation, where we can show you that how a glacier look like when you see it from space. So this is our Bhagirathi river, and we are now approaching Gaumukh glacier, or the Gomukh, which basically is the place of origination of Ganga river or Bhagirathi river, and then beyond is the solid phase of water, that is the water which is stored in this glacier in the form of ice and snow. So now you are traveling over this glacier called Gangotri Glacier, and you are able to now visualize many such peaks and many different aspects related to snow and glacier regions of Himalaya. So this type of 3D animations helps you in terms of understanding the terrain, in terms of understanding the risk and hazard associated with mountain related aspect. Similarly, using multi-date satellite images, we can monitor the flow of these glaciers, whether the glacier flow is reducing or not reducing, which basically depends whether glacier is losing mass or gaining mass. All this type of assessments are being done for major glaciers in India, and many of these glaciers are rapidly melting. So this lake formation of at the mouth of these glaciers are also being studied. You can see this is a one EMA group of glaciers in Dudh Kosi Basin, Nepal. How this glacial lake is rapidly enhancing because the glacier is losing its ice, and that ice is getting converted into water because of the increasing temperature in Himalayan region. And when these lakes increases beyond certain limits, they cannot hold this water, and many times they will breathe also and create what we call as the flash flood in these parts of the this thing, which can basically affect large amount of population which is living downstream. So we have created an inventory at IIRS itself. The glacial lake inventory for Uttarakhand has been created. NRSC has created now the entire national inventory of glacial lakes which are having potential of getting breached because of various events. So this is the glacial lake inventory in Indus, Ganga and Brahmaputra region, which has been created for around 30,000 such lakes under National Hydrology Program which is supported by Ministry of Jal Shakti. And then out of these lakes, 35,000 lakes, we are prioritizing the glacial lakes, which has basically potential for GLOF or glacial lake outburst. That means this lake can basically burst one day and can cause rapid, floods, like the case of Kedarnath floods, which has happened in the around the temple of Kedarnath. Many of you must have seen that Kedarnath movie also. So this type of situation can occur in many glacial lakes. So 5 or 6 such high priority glacial lakes have been identified using satellite data. Then some of you also must be knowing about that event which has happened in Chamoli, where flash flood has happened due to a rock slide and large amount of damage was caused. And then we assessed this damage using satellite data and also could tell immediately after the event that what has caused this particular event. This was a very unique kind of disaster which has never happened previously. Similarly, apart from this, there are a lot of activities in Himalayas happening in terms of landslides. So landslides also happen very fast. Today, we don't have very accurate mechanism to do early warning about a landslide activity, but we can use satellite data. We can use and create inventory of past landslide and generate what we call as the landslide hazard zonation maps. So those type of work has been done, and the landslide inventory and ranking of landslide exposure has been created nationally and district wise. We have generated now the vulnerability indices, and today you can know that Rudraprayag district in Uttarakhand is the most vulnerable district for landslides. And then there are other districts like Teri Garhwal district, Rajouri, Thrissur in Kerala, Pulwama in Jammu and Kashmir, Palakkad in Kerala. This is the ranking of the exposure-wise ranking at district level for different districts in India as far as the landslide vulnerability is concerned. Similarly, all along this Char Dham route also, we are also generating landslide inventory based on rainfall-based triggers and other geological, along with the geological properties. This work is also being done currently. Then we are now, very effectively thinking of using what we call as interferometric SAR technology to do early warning of landslides. This is a highly advanced technology which we are trying to bring in now. Then apart from this, there are a lot of environmental disasters keeps on happening, like forest fires. Today, using satellite data, we are generating the almost near real-time inventory of all kind of fires, including forest fires over India, and then disseminating this information to the Forest Survey of India to mitigate these fires. Fires are also associated with smoke, and this smoke causes a lot of health-related issues. So this was, the active fire locations in 2021 in Uttarakhand district, and then live fires also we can see from space, and then communicate to the ground authorities, especially the forest officials of states, about the occurrences of these fires, and then they need to manage these fires by dousing all, by generating the ground or mobilizing the ground people to go to those locations and douse these fires. Once fires have gone, large amount of area gets affected or burnt by these fires. So using satellite technology, we can also make an assessment. All this violet area what you see here is essentially burnt area. So this burnt area assessment is also being done using satellite technology. We have also generated what we call as the forest monitoring and risk assessment tools. One such rapid mobile-based app has been developed at IIRS also, and now a dashboard support is available to the foresters. They can use this geo-tagged images along with satellite data to know more about the areas which are under forest fires. Air quality is another big issue, and many of you must have experienced bad air quality in Delhi and the North India during the the winter period. And using satellite data, we can basically tell that which areas are highly under the very bad air quality and are having relatively better quality. All this kind of information is also being generated using satellite data from space. So like these areas during Punjab, biomass burning events in Punjab, October, November, farmers, they burn large amount of crop residue. So today from space data we can monitor, and we can monitor the smoke also. You can see in Punjab in the month of November, large amount of residue burning. जो राइस हार्वेस्ट करने के बाद रेसिड्यू बचता है उसको जलाते हैं. So that creates a lot of pollution problems. Smoke basically gets traveled along with wind, and it affects people as far as in New Delhi, and then also in some part of the eastern UP, and this smoke goes all the way up to West Bengal also at times. Another major thing thing which I thought I will inform you is about cyclone prediction capability in this country using satellite data has enhanced significantly. In 1999, one super cyclone struck Odisha, and the casualty figures were in four figures actually. In a super cyclone condition. But you see, this Biparajaya cyclone, it was also a very intense cyclone which has hit and long-lasting cyclone. The duration was also very high. But casualty figures were virtually nil. Only the damage to property, etc., has happened. But the human life losses could be avoided simply because we were knowing that which place this Viparaya cyclone is likely to struck and what kind of damage it is going to provide to the infrastructure. Then using our NAVIC satellites also today, whenever our fishermen they go into oceans, we are able to provide them the information about the boat location, fishing zone information, alerts about cyclone, high waves, tsunami, and then international border. Some of these people, those who are close, do fishing close to Pakistan border, intentionally or by mistake, they basically get into their waters and they are caught by the Pakistani rangers and all. So this app basically alerts them that, hey, look, you are now crossing the international maritime boundary and be careful. Otherwise, there is a chance of you getting, caught by the adversaries. So this type of information is also being provided by this NAVIC messaging service for fishermen by using the space technology. So all this information, is having no meaning until unless the users are able to access this information. आपको जब तक पता ही नहीं है आप कहाँ से use करोगे. So to disseminate and to make user aware about this, we have created what we call the National Database for Emergency Management, or NDEM. You can go to this portal and all the information related to different disasters you can find on this portal, including the disaster support services, decision support services tools also, as well as visualization support, multilingual support. Various aspects related to disaster information are available on NDEM portal. So this is in nutshell the activities, but we also need to train and to inform various people about these tools and databases through capacity building exercise. So with the help of our IIRS at Dehradun, and then ITech courses which are supported by Ministry of External Affairs, at NRSC, through our CSST AP, we plan and we do lot of long-term, short-term courses like the one which we are doing for you, so that people from different countries, different state governments, as well as central government organizations, they get aware about these type of capabilities and start using these space-based products and services. So what is the road ahead? The road ahead is that in case of multiple disasters, now we have to do disaster risk analysis, early warning systems for earthquake, etc. Wherever we are not successful, we are also launching new satellites like NASA ISRO synthetic aperture radar mission, then satellites for uh, generating information about lightning. Lightning is another major disaster which I have not covered, where large amount of human lives are being lost to lightning today in the country. So there is a lot of things are required to be done for lightning related awareness. And we have to also reduce this turnaround time. The information should be quickly available. It should be available to all through web GIS based tools. Then satellite communication in this country is still not very popular. There were certain restrictions in using satellite communication. New space policy has come out. They are trying to now overcome this, these limitations of use of SATCOM activities by the stakeholders. So all these things are happening, and with the help of advanced at night technology like small satellite, advanced payloads, new type of payload technologies, high throughput satellites for internet connectivity, artificial intelligence, to detect the disaster event on the satellite platform itself. The information availability, the time, turnaround time will reduce, and that is what will basically help our disaster managers to provide this information to stakeholders in a very fast turnaround time manner. So with these words, I will stop here and say thank you for listening this topic today in part of your training program. And I am sure that many of you must have come across the information which probably was not available to you or not talked about as far as the user space for disaster management and disaster risk reduction is concerned. Thank you very much.